Okay, so we have talked about the graphical methods, and so we already gave a function, okay, and now we will try to determine the roots of this function by using MATLAB. The function is given to us, and certainly some values are evaluated in the book, but let's see how we can do it in MATLAB. Now we have the MATLAB here. Again, we will open a new script here, and let's say that this is my function graphical method, and let's say that this is MECH310 graphical method function. Again, I will write clear all and close all in order to clear all the memory. Now, as we have seen, we have the do loop. Okay, so iteration. So remember that we have for it, and our variable is c. So of course, if we look at the function, it begins from 4 and it ends at 20, and let's write this like 4 to 20, and we close the iteration. That's okay. Now the point is, remember, or let's write it. Okay, so next thing is we have variables, right? So we have y index, we have an array of y values is equal to my function. I give a name. Instead of using f, I write my function c. Now the point is, the array index has to be 1 at this moment. So what I do is, I define a dummy variable index. Of course, its initial value has to be 0. Then I continue. It has to be equal to index, that is equal to index plus 1. Okay. So now when it makes the iteration begins from 4 and ends at 20. But the point is, as you see, it goes 4 each time. So how can I do that? Now, for this purpose, I look at the help. So let me show it to you again. So I highlight the command. I right click on that highlighted command. Then a menu is opened. Now you see smart index, uncomment, comment, function hints, and so on. And there is help on 4. Now I press on help on 4. Now the help screen is open and it tells me how it is done. So it gives me some examples. And here, as you see, it gives us an example. Okay, so in this example, the variable begins from 1 and ends at 0, 0. And there is a second line between two columns. So basically it tells that minus 0.2 is written here. So which means that here is the explanation: step by increments of minus 0.2 and display the values. So basically this iteration begins from 1 and with a step number of minus 0.2, and the final value is 0. Now I can use it So what I need is, therefore, I will begin with 4. I will give a step number of 4, and then it will end at 20. So it is like this. Okay, so let me check whether it's okay or not. Let's see the values. First, I put a % on it. This basically means that don't evaluate this comment. So it is, you see on the top of the menu there is a comment. If you press on it, so you commented that line, you can put a comment somewhere, but this basically means that MATLAB will not run this line. Line 8 is now dummy, and it will just for some explanation. Anyway, so let me write C here. So let's see whether it will work or not. It is not saved. Yes, save it. You see, now my C values are here. 12, 8, 4. Okay, so the iteration is correct. So I can delete this line. Now I uncomment this function. Now the point is, now I need to define the function which I have to find the roots. So my function, I save this M file again, and I open a new file. Again, I begin with the function. Now my function is the name. And let's say that I have the variable x. And my value is y. So I will evaluate my function, and the answer will be y. So now let's write my function here. Y is equal to, now let's have a look at the function that I want to find the roots. 9.81 multiplied by 68.1 divided by C. Then I will multiply this expression with 1 minus e to the power, so there is a parenthesis, I open it and then I close it, 1 minus exponential e to the power minus, so this is this minus 10c multiplied divided by 68.1. Multiplied by 10 multiplied by, my variable is x, by the way, so I have to make a correction. I will change the c with the x. 10x divided by 68.1. Okay. So let me correct this value with x as well. Okay. So I have 9.81 multiplied by 68.1 divided by x, 1 minus uh, 10 to the power x 68.1. So these are my functions. Okay, this is my function, and let's save it. Yes, just give a name my function, that's also okay. Now let's run it and let's see whether it will work or not. Okay, so here are the values for C. $74, $57, $46, $37, $31. Okay, so the values are different, and it seems to be that there is an error. Let's check my function. Okay, so this is my function. Okay, so I forgot to put minus 40 here in the function. So this is minus 40. Let me run it again. Okay, so these are the values that I have. As you see, it is 34, 17.7, 6, minus 2, minus 8. And let's check the MATLAB result. Yes, 34, 17.71, and so on. Now I have the values. Okay, I put a semicolon here. I don't want to see them. Now I want the x values, or yes, x values for the coordinates. Again, I will put index here, and it is C. Now I have the x values as well. Now what I'm going to do is to put figure here, plot x versus y. So the horizontal axis will be x and the vertical axis will be y. I run it. Okay, now I have the figure here. You see, this is my graph for the function. So the horizontal axis is C, and the vertical axis is the f of C. Now let's check the values. Well, this version of MATLAB is rather different. Anyway, doesn't matter. So from the graph, roughly speaking, it's here, and we can say that the root is somewhere between 14 and 16, and it seems to be that it's very close to the 15. Anyway, let's check whether I can find the value which has this in the previous versions. I have here insert color bar, edit plot, link, unlink, Let's look at the tools. I can zoom, I can rotate it. Okay. So let's zoom. So whether I can have a better estimate for 0, this is 0. You see, it is around 14.8. I can say that. Let's pan. So I just want to find the value for 0. Yes. So as you see, the root is somewhere here. It's like 14.9 something, the root of the function. So this is one way of finding the root, but of course this is not very efficient. Okay, so